Hello and welcome to the Bennett Costura Group, week 6, SE 598. This week is Augmented Reality, some limitations and opportunities.
I'm Josh Costura.
I'm Reginald Bennett.
Is,
Go ahead.
And this is the 15th of July.
It is, in the summer of 2014.
Yes, it is.
So we have a couple topics we're going to cover. So right now, MaxReality limits. Okay, so last week we talked about different projects we can do. So we want to test some more things. And so what we did was we went forward and we were testing different markers, which you can see on the ground. And we printed out a whole bunch of different markers from their PDF file. And what we noticed was there's jitter, or what I mean by jitter is there's a ton of kind of shaking or I don't know.
It looks like the object, shaking on the ground is constantly moving along one axis.
And it does that in a very snap type way. So it's not a smooth back and forth. It's like this. So it's really distracting. And the bigger the object, the easier it is to see that jitter phenomena. Now, we tested some of our own stuff, so you can see out here in the pictures where we placed the different markers, and then ran the simulation. You could see where this was supposed to be a furniture type simulation where we were seeing where you could put house plants and see what they would look like in a room. And so we assigned a house plant to each of the different markers, and we were able to move the markers around and kind of see what's going on. But you can see in the bottom right one, the one that has kind of a brass colored holder, that one had jittered into like a weird orientation, so where it's like tilted back, so it doesn't even look close to right. So yeah, jitter, that was an issue. So then we tried a couple of things as far as using static markers and movable markers. And when we had all mobile markers, the jitter still exists. The objects only fade when no marker exists. So if you pan the camera so where you can only see 2 of these markers, the third marker object, or the third object that should be represented by that missing marker, would still exist on the screen, just in the last absolute position that it was seen. So something that we talked about a few weeks ago, where if the marker disappeared, the system would just freeze the object wherever it was relative to the absolute position to the screen. And so you get the same thing. So if you scan left to right, obviously the last place you would see these objects is on the left side of the screen. And so if you scanned over to all you saw was a third marker, you'd have these 2 bunched up flower vases stacked on top of each other. It would not separate or independently fade objects. So, and again, that's with the native MaxReality application. So the ability to place 6 or 7 different objects around a room and then pan around with the goggles on in order to see what the room would look like isn't realistic with the native applications, because you'll always have those absolute placed objects. So then we said, okay, well let's check out some other things. So we tried mixing up assigning things to mobile markers and static markers. So we had one static marker up, so S0, and then mobile marker M1 and M0. And we found that sometimes the existence of a static marker would make things a little bit more stable, but if it lost tracking of the mobile markers, then they would move with absolute position to the static marker. So you could move one marker and all the other objects would move. This is again something we talked about a few weeks ago. So again, not an ideal situation. So we did a bunch of different tests. In the end, still, well, the thing you can't overcome the most, even if you were to set the conditions up to where the absolute positioning or loss of marker site doesn't matter, you still get this constant jitter. So then we want to see if it was just ours. So we went back and we looked at a couple of the demos that come with MaxReality, notably the Dragon demo. Now what we saw, what would you notice with the Dragon?
It didn't seem to jitter until we actually launched the one with the Dragon in the cage. And looking at the Dragon, you couldn't see jitter, but mostly I believe because it was a moving object. But if you watch the cage very closely, there was a slight jitter in it, and I think it has to do with the size of the object, like we talked about last week.
And then, so one, moving objects, you don't notice the jitter as much. And then 2, clarity of the marker. So while the markers were blown up in size. They were no longer this handheld size. They were made to be this much bigger so that they'd be more clear further back. I think that as the software tries to resolve the angle at which the thing exists, there's a lot more variance the further back you get. And so we notice that when we look at a marker that's closer, and there's a lot less, because the cameras don't have high resolution, when you're looking at something that's closer, and there's a lot less variability to how it could determine where the marker is, there's a lot more stability. So as opposed to before, I believe the jitter has to do with the system trying to figure out, okay, that's a marker, and at what angle is the marker currently fixed, and let's represent the object. And since it fades in and out with the resolution of the camera, it might get a slightly thinner edge, which then obviously calculates to a different angle, which is, I think, where that jitter comes out. So still not ideal, but those are things, things that we recognized and we can get around to a certain extent if we're using up close markers, as we did with the when we were selecting the objects last week.
Yeah.
So but the further and further you get back and you start having resolution issues, then you get that jitter. Yeah, so that's what we hit all the limitations, I believe, with MaxReality at this point. So there are some applications you can use it from some straightforward, easy things. But it again, as noted before, there's not a ton of complex things you can do with it. You could do some showroom type stuff.
Yeah.
I'm not sure you could do something that's functional with it.
I think if you could eliminate jitter, something like a showroom would be even better, because even with a showroom, it'd still be.
Yeah.
I think if you did a showroom, if you had the markers on the wall and had people wearing the glasses so they could stand in front of them, that would work.
Yeah, so the two things that we definitely want to isolate when we try and create our own software for this is one is not have that jitter, and then two, make sure that if a marker is not seen, either the software recognizes where some potentially visible part of the representative object should still be, or the object goes away entirely. The whole absolutely fixed to a certain part of the screen abnormally does not work for anybody. So yeah, jitter and making sure that if a marker is no longer there, that the object disappears. Those are the two main things that will be huge increases in quality.
So we also worked on Visual Studio, and we got a demo that was just a edge detection demo from another student. As you can see in the image at the bottom of the slide, that's looking through the glasses, so it detects edges. And we're hoping to use this and strip it down to its core components and start building from there. Also, as with the demos from the Vuzix SDK, we got some more work done, and we got them to build successfully. And the only problem now is 64-bit libraries and 32-bit libraries is trying to load both of them, and we can't determine which libraries are the wrong version. So that's the problem we're having now. And just to reiterate, I know I went over this last week, but what you need to include for Visual Studio is OpenCV 2. I think I used 2.4.0, even though the newest version is 2.4.9. It's a slightly older version. DirectX 9. You need to include Alvar SDK, the Vuzix SDK, and the DirectShow SDK. And each of those SDKs has an include folder, which you need to add to the project path of Visual Studio, and a lib folder. And then once you include all of those, that should be all the includes you need to add. And then with Visual Studio 2012, I noticed that there was a type error in one of the header files in the DirectShow SDK. So I had to go in and change that, just one line of that file to get it to compile correctly, and that was the last step. And we'll put that in the comments to this video probably, instead of trying to talk you through that process. But once we did that, we were able to compile, and like I said, having issues on running a 64-bit system, but I believe they're trying to compile a 32-bit program. So I need some 32-bit libraries that I don't have. So the program just exits with a very generalized error that can range from anything from compiling a program to trying to run a game, all produce the same error on a Windows system. So we wasn't able to track down that specific error.
Now, the image you'll see here relates also to our next topic, so you can kind of see there. And that's the OpenCV. So as one, we got the demo working, or that demo that was previously constructed. So again, we'll tear it down, we'll become familiar with OpenCV, and then try to get some of the functionality that MaxReality has, hopefully in a better way.
Yeah, I'm hoping using OpenCV we can actually detect the markers, because edge detection is the first step in that, but being able to detect the pattern that is a marker, I believe OpenCV should be able to handle that, and that'll get us in the right direction.
And then, even more than just the markers, and once we can get, something as blatant as a black and white marker, perhaps, being able to look at a magazine or a book and identify a character. Okay, when we see that character, let's go ahead and render something. So being able to make our own custom markers and track those. So, yeah, so that's where we're at with MaxReality. We can do some stuff with it, and if need be, that can be where we're at. We made progress, especially with finding another demo that actually works. So we'll use that, and then becoming familiar with OpenCV next week, and trying to get the core build along with OpenCV to do different phases of our dream template here. So yeah, that's it.
Yeah.
Have a good one.